Is everybody well? No? Miserable? Flu? How are you enjoying the conference so far? I'll take that as modesty. You're having a great time, right? And what beautiful weather to be indoors and listen to me, huh? We should have done this like outdoors in a park somewhere, a couple of beers, maybe some picnic sandwiches. That would be so much more interesting. So who am I? So I'm Nick Jackson. I know that. And I work for a company called HashiCorp. But before I worked at HashiCorp, I worked in the industry. I did a real job working on real systems that had real revenue and responsibilities. And one of the things that really interests me was this microservice transition that people started to do a few years back, but you know, it's an ongoing thing. And I think the thing that interested me the most was just how different things were. So in my mind, I'm just like, well, hey, I'm just going to break up this big application code into lots of little bits of application code, and everything will just work, right? No. It turns out it's actually a little bit harder, and one of the things which I certainly struggled with, and I found that is actually quite a difficult pattern in distributed systems, is authorization and authentication. And why I think this is a sort of a difficult matter is that the concept doesn't just stop at logging in and looking at permissions. There's a whole area that you have to kind of look at. You have to look at things like zero trust. You have to think about the ways that your systems are secured, because actually there could be a backdoor that this wonderful authorization and authentication system that you've built, somebody could just bypass it. And these are some of the patterns that I kind of want to talk about today. And well, HashiCorp pays my wages, so maybe there'll be a couple of little demos of how you could maybe use an amazing open source tool like Vault or something. But predominantly, I want to kind of talk about why. What is the problem? And how do we kind of deal with it? So there is authentication and authorization, right? You can't have one without the other. So authentication is about verifying identity. It's that login box. It's kind of simple. You've got sort of two things to think about when you're thinking about a system in terms of authentication. You've got actions which need to be authenticated, i.e. you need to verify the identity. And that could be something simple like a checkout or a basket or an administrative function. And elements that don't. So public websites, just browsing. There's actually a third layer as well, which is systems. So how do systems talk to each other, and how do systems manage capabilities between each other? But authorization is often something which is the difficult bit to manage in the distributed systems. So authorization, you've got to be thinking about things like permissions, right? Do I have the authority to do the thing that I'm trying to do? And in a simple world, so a very straightforward, simple, monolithic e-commerce application, the flow would be something like this. So Alice would log into the system. The system would pass Alice back, or Alice's browser, a session token. That session token, which contains nothing, it's just a random number or a collection of letters, is a thing that Alice passes to the system every time she makes a request. And that's the thing that allows the application to understand whether she has the permission to do what she needs to do. And it's handled in process. So you have something like this. With every request, at the top level of that request, you have this validate permission. So that session token is converted into a set of permissions which are potentially retrieved from the database or a data store. You know, if you're using a framework like Rails or Django or Spring, you probably find that you don't need to worry about any of that because it's just handled for you. It's built into the framework. But then you get this problem. You start getting into a distributed system. So you don't have this single block of code anymore. You've got multiple blocks of code. So again, I can log into the login service. I get my session token back. But then when I'm talking to the order processing service, the order processing service doesn't have that framework. It doesn't have that ability to make an in-process or maybe use a session sort of lookup to determine what permissions I have. So how does it understand if I can do what I need to do? And this is kind of a core problem with distributed systems. We kind of need to work out whether a user is authenticated, but we also need to understand, does this user actually have the permissions they need to do? So you could do something like this. You could kind of say, well, I got my login service, so I'm going to log in to my service. I'm going to get my token. And then each of my individual services, so say I want to retrieve my user details or update the catalog or fetch them in the basket, is going to take the same session token and it's going to make a call to a centralized login service and get back those permissions. So what are the problems with that? I mean, there's a number, right? So those calls are potentially going to be taking place over HTTP. Those calls are potentially going to be taking place across a machine boundary. So it's no longer in memory. It's not even going from network transport on the same machine. You could be going from a completely different machine. That's going to add latency. But what you're also doing is you're creating the busiest service in your system. Because if one request to your front-end service translates into 3 requests to your microservices, and each of those are making a call to the login service, then that's now incredibly busy. That's going to get a minimum of 3 HTTP calls for each one request. So you think, well, I can work around that. So what I'll do is instead of the login service returning a session token, I'll just get it to return the permissions until. You see, one of your users, let's call her EvilAlice, just to differentiate from Nice Alice, but she realizes that you're getting this plain text permission bundle back every time she logs in. So she changes it, she makes herself an administrator, and she does anything she wants. So that's a problem. So you think, well, hang on a minute. What if I implement like an API gateway or a BFF, back-end for front-end type pattern? And what I'm going to do is my front-end service is going to make a call, get my user permissions and my session token and all of that sort of. So that's all nice and constrained. So EvilAlice now can't just modify her permissions. Or can she? You see, what we've done is we've put implicit trust. So the user details service, the catalog, the basket, there's now implicit trust there that when they have a request with a permission, that it should just trust that. And the one thing about network security is that we should actually be thinking about zero trust. So we should be treating everything as a threat. Because in an instance like this, EvilAlice is no longer going to just modify those permissions in her browser. Well, what she does is she finds an exploit in your front-end service. So she finds that she can do remote code execution because there's an eval bug in the JavaScript framework that's running there, and that gives her access to your network. Now, once she's in your network, well, she can build that token and pass it on to the service however she wants. And because the services trust any request from within that network, all is good. So when I mentioned earlier, and I said, we need to be thinking about zero trust. Authentication and authorization is not just about login and permissions. There is a much, much wider scope. We have to think about this, right? I mean, seriously, you've got to be thinking that every request is hostile. You've got to think around the fact that perimeter security is not enough. It isn't. I mean, look at the most recent attacks that have happened. Some of the biggest ones, you've seen things like struts vulnerabilities, which have allowed an attacker access to a system. You've seen a number of sort of JavaScript vulnerabilities. These are kind of easy pickings. WordPress is one of the most attacked systems, probably because it's one of the most used. But you can't trust perimeter security because there's always going to be a way for an attacker to bypass your firewall and get inside your system. And it's not necessarily the vulnerable system, the one where the exploit occurred, that's the one that's going to be taken advantage. They're going to get into your system and they're going to move laterally around it, exploring to find the exploit and the thing that's going to do you the damage. So how do we do this? So we need to implement zero trust. We know that just because a service is sitting inside the perimeter of a network or a firewall, that it can't have this implicit trust that every request is valid. And how do we build this in a sort of a distributed and in a scalable way? So we could literally spend the entire of the talk working on building an Auth system. But actually, I think one of the patterns which is probably one of the most prevalent right now is OAuth, OAuth 2. And I think in addition to OAuth 2, what we're going to look at is the extension, which is OpenID Connect. So OAuth, it's an authorization framework. It's designed to allow third-party applications authorized access to your particular resources. And it kind of solves this problem of credential sharing. You don't need to log into each and every service, but it's solving the problem of trusted access as well. In terms of kind of how it works, let's have a hypothetical example. So you're on Facebook, and you see that, hey, there's an interesting personality test. I'm keen to find out what my personality is, because I'm a sunny, people-loving type of person, honest. So I click on the link. And the first thing that happens is that I bounce off to another site, but the site informs me that I need to be authorized to continue with this. So what happens is the other site bounces me to Facebook. You might see the little pop-up in your window, and it says, my super personality test by Cambridge Analytica wants access to all of your information on Facebook, including all of your friends' information and your friends' friends' information, and pretty much everybody on the entire planet's information. And you just say, hey, yeah, what the hell? I want to do this test. So it bounces you back. You grant the access in Facebook. Facebook gives you a temporary token. You give that back to Cambridge Analytica. They swap that for an API access token. So now your personality test's loading. Cambridge Analytica can then have got the authority to contact the profile and the various other different Facebook API acting on your behalf. So they pull that profile picture of you slightly worse for wear in Amsterdam back in 1991. And they do some other stuff, but you take your personality test, you find out, actually, you're not really a sunny, happy, people-loving person at all, and in fact, you're more introverted and people-hating, and you like a darkened room and silence and isolation. But you took that personality test, you've authorized Cambridge Analytica to use your data and your friends and the friends' friends and friends' friends and friends' friends. You're actually responsible for electing the biggest idiot in world politics and the downfall of probably one of the greatest economic unions that exists today. Look, I mean, that was a sort of a simple example with some rather terrible stereotypes for which I do apologize. I don't apologize for poking fun at the orange chap, because he deserves it, but that's the sort of the concept of the OAuth flow. And it allows this service to have the various different ability to access third-party data, this delegated access. But the problem with kind of OAuth is that whilst it's incredibly useful, it doesn't really solve this problem of identity management. So one of the things that people started to do was they would kind of not abuse it, but they would use OAuth 2 for authentication and for identity management. And the problem with that was that because there was no kind of written specification, there was no written standard, everybody was kind of doing something different. And the kind of the custodians of the framework, well, they kind of decided that there needs to be a more formal specification around this. And this is where OpenID Connect comes in. So with OpenID Connect, this is the extension to the OAuth 2 framework, but it deals specifically with this identity management and this authorization process. So whilst OAuth 2 didn't have any like formal specification on any kind of token, OpenID Connect does. And OpenID Connect states that you're going to use JWT, JSON Web Tokens. Now, whether you're rolling your own framework, whether you're going to use OAuth, very much depends on where you are in your application lifecycle, right? So if you're building greenfield, it's easy to say, hey, well, we need login, we need authorization, so we're going to implement a brand new OAuth 2 setup. If you're doing a microservice decomposition, if you're kind of doing more brownfield, then replacing the entire of your login systems possibly not going to happen. But regardless of what you take, one of the sensible specifications, which has received its own amount of criticism, is this JWT. And I want to talk more about JWT because it's going to a potential way of solving this authorization problem. So if you're not familiar with the format, it's broken up into 3 sections. So you're going to have your header, you're going to have your payload, and you have an optional signature. So the header, predominantly 2 elements which you're going to see most of the time, and it's a JSON object. The payload, again, is a JSON object. Anything that can be encoded into the JSON format can go in there, and we'll look at these 2 in depth. But when you see it represented, if you look at it in your browser or if you see it sort of passed, you're not going to see it in this raw JSON form. What you're going to see is this form here, which is the compact serialization form. And each of the elements, you can kind of just about see the dots there. So we have the header, and the header is base64 URL encoded. And then on the next line, and I've added the lines just for readability, but the payload, again, base64 URL encoded. And finally, we've got the optional signature, which, can anybody guess what the encoding format is on the optional signature? Yeah, it's base64 URL encoded. And base64 URL encoding is not so much similar from standard base64. The main difference is that you've got the plus and the slash, which are replaced with a minus and an underscore, and that's literally just so that this JWT could end up in a URL or other format without causing a clash. But in terms of the detail, in terms of those elements that you're going to see in the header, well, you've got alg. So this is the algorithm. So if you're using a signature or a signed JWT, the header is denoting this is the algorithm that you're using for that signature. So maybe RSA, it might be ECDSA. And then you have the type. And the media type of the JWT, I've never really seen this have any other value other than JWT. But it's there. I mean, so the baffling official documentation states, and I kind of want to read this because this is intended for use by the JWT application when values that are not JWTs could also be present in an application data structure that can contain a JWT object. The application can use this value to disambiguate between the different kinds of objects that might be present. I think the key thing is, algorithm is predominantly the main thing that you need to look for. The content type CTY is also useful, and if you're going to use things like encrypted JWT, so quite often people will create an encrypted JWT and wrap it in a signed JWT. More often than not, when you're just kind of using them, you're literally just going to be concentrating on the algorithm. You're just possibly going to be using signed. You're not bothering with encryption, and you don't need to worry about yes. So the payload is where the interesting bit happens. I mean, this is where you're going to encode various claims. This is where you're going to kind of set out the permissions and things like that for your application. But there are also some sort of registered elements which are part of the specification. And these are really, really important because we need to use these when we're going to validate our tokens. And we'll look at that in a bit, but just for now. So you have ISS, and this is the issuer. So this can be a string, maybe a URI, but this is the system which has issued that token. And then the subject, so sub. So again, that's a string or a sort of a URI, but that is referencing to whom this JWT belongs. So that could be me, it could be a system. And the audience, aud, so for whom is the JWT suitable? And audience is actually a useful parameter because we need to be thinking about this and using the audience again when we come to validation, because we shouldn't, as a system, just accept any old JWT and just validate it. We've got to make sure that it's specific for us. Expiration. So you've got a token, you've got a signed token, and it's really important to have a life cycle on that. It can't just be infinite. So if you log in once, then you can't just have that token that exists until the end of time. Because if you think back to our distributed system, the distributed system isn't making a call to the authorization, to the login service. So when it receives a token, it's going to check the validity of it, but it's now trusting that token. If that token has no expiration, then I could log in once, you could revoke all of my permissions, but if I keep hold of the token, I can use it forever. So expiration is incredibly important, and generally what a lot of people will do, because it's difficult to manage the expiration, is to use short TTLs on tokens. So use a short TTL and give a user the opportunity to refresh. Things like refresh are built into the OAuth spec, but if you're rolling your own, you need to be thinking about that. Not before NBF. So in similar, the opposite of your expiration, this token is not valid before this particular date. And then you've got the issued time, so IAT, issued at, when was this token created? And JTI. So JTI is a really, possibly a quite useful element. In some instances, you might ignore it, but it's the token's ID. So where this becomes useful is when you think about things like a replay attack. Right? So what's a replay attack? Well, a replay attack is that, for example, I make a request, and then somebody captures that request, gets the information, and makes another request, potentially with a little bit of redirection. With using like the JTI, what you can do is, if you decide that a JWT is a one-shot, it's a one-use token, then you can store the token ID in a data store somewhere, and you can ensure that that's only processed or used once. So the stuff that you're really going to be interested in are predominantly the sort of the private claims, but again, you have public claims. And to be brutally honest, in my humble opinion, I haven't found these particularly useful when I've been implementing, but there are public claims which are in the IANA register, and they define things like name, profile, email. And the reason why you should be aware of them and why it's useful is that you've got to avoid collisions. So if you register your own claim, then it can't necessarily contradict one of these existing ones. Now, the private claims are really where it starts getting useful, because your systems are custom. You're building something completely different. You need to define what a kind of a permission or a claim looks like on a service-by-service level. And by using the kind of the private claims inside the JWT, what you can do is manage that. So I could have a claim which is, for example, basket.update. And that's something that my basket service would understand. Update is an action, the value is true. Or profile.modify. Or I could define a JSON object, so I could just have an array. So anything that can be encoded as JSON can go into these private claims, and how you build that is very much on what your application looks like and how you've kind of modeled the permissions within that system, but it's fairly flexible. So one of the less useful features, I think, of JWT is that the JWT, it is a loose framework. So you don't have to sign and you don't have to encrypt a token. And in fact, this ability to have an unsecured token that we'll look at in a little bit is actually some of the reasons that there's been a lot of vulnerabilities and sort of negativity directed against it. But previously you had the header, you had the payload, but the signature's optional. So I can define my header like this. I specify my algorithm as none. My type is still JWT, but I don't need to specify the signature. Now for validity, what I do need to specify is the trailing dot, but nothing needs to come after it. Where JWT is incredibly useful is around that ability for validity, the ability that a system can validate and trust a token. And with that, you have web signatures, so JWS, which is the kind of the framework. And what you can do is you can set up your system to sign and validate a token, and it can use symmetrical or asymmetrical encryption. So you can use a shared secret or something like public-private key, so PKI. The signature is actually the product of the header and the payload. So if a malicious individual decides to modify either the header or the payload, it'll mean that the signature is no longer valid, so your system will reject the token. It knows it's been manipulated. So now your system, if we look at our previous example, looks something like this. So I log in, and instead of just getting any old token back, I get a signed JWT. I can then pass that JWT to my service. It can then pass it down the line, and each of these individual services is going to perform validation on that token. So it's going to validate that the signature matches the message. So whereas before, EvilAlice could just use a vulnerability in your front-end system, and she could craft a token which she can then send on to any other services, and because the services just implicitly trusted everything into the network, that doesn't work anymore. Because what Alice has to be able to do now is she has to be able to create a token and sign it. Not impossible, but much, much, much more difficult. So whether you use a shared secret or whether you use a public sort of key approach is very much depending on what you kind of want to do and how you build your systems. But one of the things I really like about asymmetrical encryption is that the secret, the private key, I only need to worry about it in one location. I only need to secure that in one single location. If I'm using a shared secret, then in order to validate a signature, each and every application has to have access to that shared secret, which is a much more complicated problem. And then you've got to think about algorithms. So there are a number of algorithms which are available in the JWT sort of format. And to be honest with you, if you do a little bit of Googling around the web, you'll find that, again, there's a little bit of criticism because the specification hasn't necessarily removed some of the weaker, vulnerable encryption algorithms. But predominantly, you're going to kind of think, well, I'm going to either use elliptical curve or I'm going to use good old RSA. And that choice is down to you. So some of the things that I think are in the benefit of something like elliptical curve is its speed and performance. So it was designed to be fast. And in fact, it'll perform in some ways like 20 times the speed and performance of RSA. So for a much smaller and faster key with elliptical curve, you're actually going to get a stronger encryption algorithm. But again, like everything, there's a caveat. You've got to be careful with what you're doing. One of the interesting things, I think, around sort of RSA is that there's been reports, and it's believed that within about 5 years, the RSA encryption algorithms will be breakable. So it doesn't leave us a lot of options. Elliptical curve's pretty new, but it's actually getting pretty widespread support now. So you'll be able to use it for things like X509 certificates. It's fairly widely available, but just be careful on which implementation you use. If in doubt, do remember, complete disclaimer, that means legally, if you implement anything and get hacked, I can't be sued. But joking aside, it is complicated. And if you have the ability to consult an expert, if you've got sort of an information security team in your organization, speak to them, get their advice. If you can't do that, then you can dig around the internet. You can look at, what does Google use? What does Cognito use? What does Authz use? There are ways of determining an algorithm by standing on the shoulders of giants who've probably got huge information security teams. With JWS, you also get a whole extra bunch of headers, and I'm not entirely certain all of these are particularly useful to me, but the one that I am really interested in is KID. So KID is the key ID. So one of the problems with an attack that's happened previously with JWT is that an attacker will just change your algorithm to none. And your validation code will blindly trust that this isn't signed, so it won't even bother checking the signature. Now, that's an implementation problem or a framework problem, but key ID and the potential deprecation of the algorithm header in favor of something like key ID, which is just a string value, just giving your application a hint as to which key it should use, not even specifying the strength or the format, could potentially go a long way to helping things out. You can also do web encryption, so JWE. So your tokens don't just have to be signed. You can encrypt them, and there's a format to doing that. My personal bias on this is that signing is good enough. So your contents of your token or your claims shouldn't really have anything that you're worried about leaking. If you leak the fact that I've got access to the basket service, no big deal. You shouldn't be doing things like encoding my account IDs or my kind of profiles or anything like that, because JSON Web Token is not a replacement for session state. You could use it alongside session state, but don't go encoding everything that you would put into your standard session into your JWTs. Full encryption is also slightly slower than signing, and again, that's another major concept that we've got to think about in a distributed system. So I've mentioned a couple of times, yes, there are problems. You don't need to Google very far. One of the top hits is, I think it's an article called No Way Jose, which is it's a great read, and you should read that because the author has some very valid points around problems with the sort of the looseness of the specification. The author is also the creator of something which called PESO, which is another framework similar to JWT, but it's more opinionated and it takes a more security-first approach. So that's something else that maybe is worth checking out. But that ALG-NON attack, it was beautifully simple. So EvilAlice, well, she logs into the system and gets a JWT. And she looks at that and she sees that you're using 256-bit RSA encryption and a signature. So she modifies the payload, removes the signature, and changes the algorithm to none, creating an unsigned JWT. Submits the request. Your service validates that JWT. It looks at the header for guidance as to what the signature is. And of course, it picks up that the algorithm is none. So it just allows it through. And this was, again, a problem with the implementation, that the code that was implementing the validation for these tokens just wasn't taking, it was trusting something which could be manipulated and modified. If you look at a lot of the modern implementations, you'll see that the signature algorithm has to be explicitly declared for validation. So in fact, it's going to be completely ignoring the algorithm header, but it's something to think about. It's something to double check that your library is actually doing. Another really interesting kind of abuse of a very similar approach with that is that if you had a token which was using RSA, public key, public-private signing, an attacker would again change the algorithm and use that as an abuse. So EvilAlice takes your JWT, which is signed, and this time, because the keys may be being passed into the code so the algnon attack isn't going to work, what she does is modifies the payload. She modifies the payload, and then she uses the public key, which is used to validate the JWT, to sign the message. Now, she's also changed the algorithm, so she's changed it to an HMAC rather than a public-private key, so shared secret. So you submit the request, the service validates the JWT, reads the header, it determines that it's not using asymmetrical approach, it's using symmetrical encryption, and it's using the key which it's already been provided to it, which is the public key. So it validates the request. It uses the public key to check the signature by generating a new signature from the message using the public key as the input source. And that actually marks it out as valid. So again, another issue around the sort of the algorithms. Weak HMAC, again, this is more a sort of a problem of cryptography. Nothing is infallible. It is possible to brute force. And you've got to be careful if you're doing things like HMAC that you're using a strong enough key and you're using strong enough level of encryption. So best practices. You must ensure that you're performing this algorithm validation. Literally, like when that whole algnon thing blew up, most of the libraries have been changed. They've been to implement this special sort of specific approach where you dictate what the algorithm is and what the key is that's going to be used, or the shared secret. Don't let it up to the header to determine that. Make sure using the right algorithm, so get that balance between speed and safety. Make sure you're using a strong enough algorithm so it can't just be brute forced. And always do your validation. So make sure you're checking the expiration, you're checking the before date, you're checking the audience and things like that. Again, a lot of the libraries will do this for you and just kind of save you a little bit, but you've got to make sure that this is happening. So that's all well and good, right? So we know that our services, we can use JWT. That's solving a problem of the authorization between services. But we'll get back to zero trust. Authorization and authentication takes a much, much wider approach. Passwords. So, have I been pawned? There are over 5 billion accounts which usernames and passwords and details have been retrieved from. So if your app hasn't been hacked, why should you care? Well, you should care because who uses the same password for a number of different sites? And be honest. Right. And why do you do that? You do that because you're human. And because you've got 1,000 different logins and, okay, you can use one password, but sometimes it's just easier, right? But this is a key thing that you've got to be thinking of, because even if your site hasn't been hacked, then somebody else might have been, and your user might have an account on that site, and they might be using the same password. In addition to sort of Troy's 5 billion, there's also a plain text document floating around the internet where you can get a list of usernames and passwords. So decoded passwords, 1.4 billion. And they've been retrieved from sites like Bitcoin and Netflix and MySpace and some things that nobody ever looks at, like Minecraft. But that's plain text. So that's a dictionary list that somebody can use to immediately brute force the authentication on your site. But we can be happy. It's not all doom and gloom because of that list, password is no longer the #1 most popular password. So I think let's give a big cheer for humanity. However, I mean, you seriously, you've got to be thinking about protecting your users because not everybody has the technical skill to protect themselves, and two-factor authentication is a really nice way to kind of do this. If I can. If that video would play. Bear with me. Okay, so plugging Vault here. Two-factor authentication really shouldn't be difficult to implement. So I've got a little example service. And if I was going to use something like HashiCorp Vault, then I can do it really easily. So HashiCorp Vault's got a one-time password secrets engine. Really easy to set up and create. So 2 simple commands and I can generate a one-time password for my user. Now the interesting thing about this is the barcode there is actually a base64 encoded image. So I don't even need to generate the sort of the images to allow people to do that two-factor authentication. Vault's going to generate it for me. I can then use something like 1Password, and I can set up 2FA, or you can use Google Authenticator or Authz, or any number of different devices. But like the heavy lifting is all done for you. And these are the important things. You don't want to have to write a lot of this stuff because you could be writing your own bugs into it. You can use open source tooling. Validation, again, super simple. I'm kind of showing it on the CLI here, but actually using the RESTful APIs, it's pretty much a very straightforward call. Again, so there's a little bit of implementation code, just using the Vault client inside my application. 10 lines of code to be able to enable that. Super easy. This is something that we need to think about as well. So insecure deserialization. Because actually, if you've implemented this amazing authorization, this amazing authentication-based system, there are still possibly vulnerabilities. So the vulnerability here is the message queue. If my clicker worked. So again, the hostile actor is just going to execute some sort of remote arbitrary attack at any point of the system that's going to gain them access behind your perimeter. Once they're inside, if they can discover that you're using a message queue-based system and then they can get access to write messages onto that, then actually they don't need authorization anyway, right? Authorization is happening at this point here. However, again, we've got a trusted system. So this transaction processing system trusts the security connection between the message queue and the transaction processing system. which may not be secure at all. So in an instance like this, the hostile actor has completely bypassed your authentication and your authorization system by manipulating queues. Why is that important? It's important because in addition to building out microservices, one of the other important patterns is very much an asynchronous event-driven pattern. Whether you're doing fully blown DDD or not, the chances are that you're using events somewhere out in the system. Again, don't trust your perimeter security. Message signing. Again, you've got to think about when it's appropriate. If you're making a sort of a financial transaction, then it's maybe appropriate to sign messages. If you're sending an email, you may determine that that's not appropriate. But again, you can leverage something like Vault to be able to do message signing for you. The transit backend, so that means that nothing is stored inside of Vault. It's just performing the cryptographic work for you. And I can generate signatures, and I can validate the signatures. So rather than managing my own public-private keys, like I was with my JWTs, I can actually also use something like the transit backend in Vault to sign and validate JWTs, which is what we actually do on our licensing server at HashiCorp. And again, back to that topic of zero trust, but data in transit. How many people implement HTTPS right the way through their microservices? Not just the front end, but the back end. So a few. And there's a reason why you do that. And the reason why that you do that is, again, because you don't trust perimeter security. So I've got my order processing system, I've got my JWTs, my transaction processing system is going to validate my tokens, I'm all nice and secure, except I'm using standard plain HTTP. And what that means is that a hostile actor, if they can gain access to my system and they can gain access to my network, they can read that traffic, they can pick up that web token, and they can just replay it. Implementing HTTPS between your services is absolutely essential. Even using something like a service mesh, which is a popular pattern, which is going to give you that sort of restricted route for your network traffic, or controlling your routing tables, however you do it. But you need to encrypt the transport. It's not easy. I mean, it's getting better. It's easier. There are a bunch of tools which you do it. If you're using something like Envoy or any of the other sort of service meshes in Kubernetes, then being able to sort of generate and manage HTTPS certificates is a lot easier. I'll just quickly show you yet another demo, because maybe you want to use HashiCorp Vault. You hear it's a great tool. But seriously, one of the strengths around Vault, again, is enabling all of these kind of mundane, yet actually pretty difficult things to do. You can enable the PKI backend. You can set up some of the various tunings, so I can set the lease TTL, so how long is that certificate going to be valid for? And I can use it to generate certificates. And Vault will generate the certificates, it'll give you the key and the cert, you can get access to the full trust chain, so if you're using intermediate signing. But it just kind of avoids the management problem of having to deal with that manually, having to manually provision certificates, having to generate them specifically every time a service comes up, because you want to lock it down to a particular IP address or a domain name or sort of whatever sort of service discovery that you're using. It's a free tool and it's really, really easy to use. So in summary, authorization and authentication doesn't stop at the login process. You really have to think about the entire of your system, not just the perimeter boundary. You need to have zero trust absolutely everywhere. If you can, I wouldn't build my own login system. I would delegate that responsibility to using GitHub or Google or Facebook if you're writing personality tests. But you know, if you can, avoid the work of having to store usernames and passwords in your own system. You can implement an OAuth 2 process. You can delegate the actual login to an external system and let them worry about security. Signed tokens. Don't build that implicit trust. Just because something sits behind the perimeter doesn't mean that it should trust another system. It should have no trust. So use something like JWT or Peso, or you know, there's a number of different things out there, but use something which is signed and something which is valid, can be validated. If you are using a token, make sure that you're implementing the validation correctly. And think about this in terms of your application development flow as well. Who puts security as day zero when they're building a new service? Couple of people. Who puts security as an afterthought, potentially after you've gone live because you're getting rushed to crank out a service by a project manager? Right. It's not unusual, but if you think about the secure aspects when you're building a system, when you're going through those initial conversations, and you make sure that task one that you're going to do is to cater for those elements such as token validation and the integrity, then you're not going to get to the end of the project when you don't have time because you're rushing out a feature which you don't think is particularly useful, as we all do. And you never get to implement that security. Take it as a first step principle. If you need to, and certainly for anything that's maybe got financial transaction or anything that's manipulating data, if you're using async message queues, sign your messages. Message signing is going to give you pretty good throughput. It's not anything that's going to really slow down your system as such. And if it does, you should be thinking about scaling it up to protect yourself. And do your research. Make sure you're using the right cryptographic algorithm. Make sure you're not using something which can be brute forced easily. And thank you for listening. I can't remember if there's any questions, but I'm going to ask if there's any questions anyway, and certainly we can you can grab me in the hallway. Oh.
What about inter-service authentication authorization? I mean, when the user is not involved in the process.
Yeah. So inter-service authentication. So again, you can take a similar approach. So one of the things that you could do is use something like Vault, have an app ID, because you need that initial service, and again, just generate the tokens. So you might determine that you provision you create the token at like provisioning time when you're actually deploying the system, or you may decide that you're going to do it sort of another thing. The other thing that you can do is that ask yourself the question of whether you need a token or whether an API key is actually a suitable approach. Because more often than not, if you've got inter-service communication, you might get away with doing something a lot simpler, which is just restricted access API keys. What is the best way to revoke a token? I was hoping nobody was going to answer that. So you've got to think about maintaining a blacklist, and that's an unfortunate point of a decentralized system like a token-based system. So a refresh token is likely going to have a much, much longer lifespan than the actual ID token itself. And that's by design. But what you can do and what you'll have to do is have a blacklist. So if somebody logs out of the system, then you basically mark that refresh token as culled inside a database. So when the user goes to use the refresh token to update their ID token, it's going to get hit against the blacklist and it's going to be rejected. But that's the only way to do that on that one.
What is the best way to implement navigation? You mentioned when I come to one service as a user,
yeah.
then the service goes to another service as a service. Is it the best way to go as a service, as is the best way to have user token as well, or just use user token to navigate this request?
So you can, if the service request in that instance, what is the question was, what is the best way to sort of manage the fact that you hit service A and service A needs to talk to service B. So what I would recommend is you've already got your web token, which is marking the user's claims and their identity. Just forward it as part of the request. There's no real problem in doing that at all, because actually the action that's performed in service B is still relating to the user. So just take the token and forward it on with the request to the downstream service. Any other question?
Do you have a recommendation where to store the shared secrets?
Do I have a recommendation of where to store shared secrets? I do. So there's a little open source product called, in all seriousness, I genuinely would use HashiCorp Vault. So what Vault does is it gives you that policy-based access to your secrets. So if you're using a shared secret, you can assign an application particular access to that. So for example, if I'm using PKI, service A may have access to the private key. Service B might only have access to the public key. And that's controllable via policy, and you can set the various different TTLs. All of the data inside of Vault is stored and it's encrypted. If you're not using Vault, then you can put them in S3 and use KMS or something like that, but make sure it's all stored in encrypted. The thing that you've got to be aware of and be careful of is that the wrong person gets access to your shared secrets. But yeah, there's a number of ways. Vault, S3, KMS. Google has their cloud storage with their key management solution and stuff like that. Any other questions? Then sorry. Oh, I'm so sorry. Yeah, can you just repeat that again? Sorry.
Can Vault help me to distribute my PKI?
Yeah. So you can use the transit secrets backend actually in Vault, and Vault allows you to generate like ad hoc keys, which you can then retrieve. Again, the policy allows you to determine whether you're only allowed access to the private part or the public part of that key. So yeah, there's a number of different ways to do that, but absolutely check out the key management solution in Vault. The other thing with that as well is it gives you automated key rotation. So you've got the capability of having two keys in existence at any one time while you're rotating from key A to key B, which is another key feature in any form of symmetrical or asymmetrical approach. If you're using keys, you need to be rotating your keys on a regular occurrence. So Vault is written in Go. So if you're a Go programmer, you can write various plugins which might extend its capability, but ultimately for the bulk of the access, the normal way that people are interacting with it, they're using two different things. One is the worst named piece of software in the world, which is console template, because console template doesn't just allow you to gain access to the key value store in console. It actually gives you access and life cycle over secrets in Vault. The other way that people will use it is through something like just the client API, and that's just a RESTful a RESTful API. So you can use that. You can have Kubernetes delegate a Vault token to your pod, and then you can use that token against the RESTful API. So it's pretty flexible, pretty easy to use from that perspective. You don't need any specific clients or anything. Any last questions? I think we're getting hustled out of the door because it's lunchtime, but thanks again. If you do have any questions, I'm floating around the conference for the next couple of days, so please come grab me if you want to steal stickers or anything like that. Thank you.